Hello everyone. For today's video, we are diving into one of the most practical uses of integration, which is finding the area under the curve. We'll learn how to calculate the exact space between a curve and the x-axis over a given interval using definite integrals. I'll guide you through the different types of area questions and show you how to apply methods step by step. So let's start with the first question over here. In the first question, you can see that you have a graph. This is the shaded area, and we actually are always looking for the area of the shaded region only. So what we have to do is we need to find the entire area of this area under the curve, and then we are going to deduct or minus off the other shapes below it. So let's look into the question now. The diagram shows the curve of y equals to 6x minus x squared for x between 0 and 5, and the line y equals to x. Find the area of the shaded region. So to find the area of the shaded region, first of all, what we're going to need to do is we're going to need to integrate the curve. So integrating the curve between 5 and 0 and 6x minus x squared, right? What we're going to do is the integration of 6x is 6x squared over 2. The integration of x cubed is minus x cubed over 3. And we are actually going to do it in between 5 and 0. Then the next step is to just substitute 5 in and 0 in. This simplifies to 3, 5 squared minus 5 to the power of 3 over 3 minus 0 of this. So this is just 0, right? Typing this part into the calculator, you're going to get 33 and 1 over 3. For me, I will always leave my answers in fraction because it is the most accurate answer. Right. The next thing we're going to do is we're going to find the area under the curve, the triangle part here, because we're going to use this 33 and 1 over 3 is actually the entire region here. We're going to minus off the triangle, and to find the area of the triangle, we need the base and we need the height. The base is 5, and the height over here, the coordinates y is equals to x, right? So when x is equals to 5, y is also equals to 5. Therefore, you have a triangle of base 5, height 5. I will write down that the area of the triangle that we're looking for is half times base times height, which will give us 12.5. Finally, the area of the shaded region is just 33 and 1 over 3 minus 12.5 to give us 20 and 5 over 6. Okay? This is your final answer. A simple question for the first example. Now, let's look at the next question. In this question here, the diagram shows part of a line for 10y is equals to 7 minus 3x. You need to remember to change this into the y equals to mx plus c format. And a part of the curve of y equals to 1 over 3x plus 4. The line and curve intersects at point A. Verify the y coordinate of A is 0.1 and calculate the area of the shaded region. So we can follow the steps by steps in the question here. First of all, we're going to verify that A is equals to 0.1. And to do so, we have to let both the equations equal to each other. First off, we have to change this back into the y equation first. Make y the subject. Y is equals to 7 minus 3x over 10, right? And then we're going to let this y equals to this y over here. 7 minus 3x over 10 is equals to 1 over 3x plus 4. Solve the x equation from here. 7 minus 3x multiplied by 3x plus 4 is going to give you 1 times 10, which is just 10. Expanding the bracket here, you have 21x plus 28 minus 9x squared minus 12x. Bring the 10 over. Minus 10 is equals to 0. Then from here, you just have a quadratic equation. Simplify this, you're supposed to get negative 9x squared plus 9x plus 28 minus 10, which is 18. Sorry. 18 is equals to 0. Then type this part into your calculator. You would have gotten that x is equals to either negative 1 or x is equals to 2. When x is equals to 2, okay, sorry, we have two answers over here, right? Either x is equals to negative 1 or x is equals to 2. But obviously, if we're looking for the coordinates of A, this coordinate has to be 2. It doesn't make sense to say that this is negative 1. So negative 1 is probably somewhere here eventually where they will meet. So this is your negative 1 coordinate. But since we're looking for A, we are just going to ignore this, ignore negative 1, right? And when x is equals to 2, substitute it back into your straight line equation. Y is equals to 7 minus 3 times 2 over 10. This is 7 minus 6, 1 over 10. Y is equals to 1 over 10, which is also equals to 0.1. Therefore, the coordinates of A is going to be 2 and 0.1, right? This is the verifying part. Next, we're going to calculate the area of the shaded region. So let's look back at the curve over here. If we're looking for the area of the shaded region, what we're going to need to do is we are going to need to find the area of this triangle here minus the area of the area under the curve up to A, and then minus off this triangle area here again. Okay, so let's try to do it step by step from here. First of all, what we're going to do is we're going to find the area under the curve first. To find the area under the curve, we are going to integrate our y equation. Integrate integrate between 2 and 0, right? 2 and 0, the equation of 1 over 3x plus 4. This will actually end up becoming a ln, right? So when I'm doing integrations of fractions like this, I will always leave some empty space in the front. Ln 3x plus 4. And then internally, I will be thinking, all right, if I differentiate 3x plus 4, I'm going to get a 3 on top, but I'm only supposed to have 1 as my integration. So this will have a multiple of 1 over 3. 1 over 3 times 3, you're going to get the 1 on top here, right? Then it's in between 2 and 0. Now we can do the substitution. 1 over 3 ln 2 times 3, 6 plus 4, that's ln 10, minus 1 over 3 ln 0 times 3, 0 plus 4, that's ln 4, right? Now this is going to be the area under the curve. Simplify this equation, you would have gotten 10 over 4, so it's 1 over 3, 1 over 3 ln 10 over 4 is 5 over 2. The area under the curve here is 1 over 3 ln 5 over 2. Next, we're going to need to find the area of the triangle. So we're going to need to have this coordinate here. This coordinate is just simply when x equals to 0. When x equals to 0, when x equals to 0, y is equals to 7 minus 0 over 10. Y is equals to 7 over 10. So the coordinate, the intersecting is y-intercept, yeah, is 0, 0.7. Amen. The next thing is we're going to need to find the x-intercept as well. The x-intercept is when x equals to 0. I mean, sorry, when y equals to 0, right? When y equals to 0, so 0 equals to 7 minus 3x over 10. Therefore, oh, oops, sorry. Therefore, 3x equals to 7 and x equals to 7 over 3. Therefore, the x-intercept is going to be 7 over 3 and 0. Okay, now to find the area of the triangle, of the big triangle, yeah, the big triangle, this one here, is going to be half times the base, which is mentioned earlier, which is going to be 7 over 3 times the height, which is 7 over 10. Type this into the calculator, you would have gotten 49 over 60. So the big triangle minus the area under the curve minus the small triangle. So let's find the area of the small triangle as well. The area of the smaller triangle is going to be half times, from here is 2 to 7 over 3. That's just 1 over 3. And we know that the height was 0.1, right? 0.1 is 1 over 10. So the area of the smaller triangle, this, when you type into the calculator, is 1 over 60. Finally, the area of the shaded region is 49 over 10 minus 1 over 60 minus 1 over 3 ln 5 over 2. When you type this into your calculator, your final answer should have been 0.495 into 3 significant figures. So yeah, this is the gist of the question. You will always have like compounded shapes, and you would need to find each individual area individually and minus them off as your final answer. Okay,